Hello everyone, welcome back to our class of business statistics. And the thing which we are going to cover today is something beyond normal averages or normal mean. So as of now, or until now, you have calculated the arithmetic mean, or you would have dealt with mean of ungrouped data, group data, and in-group data, discrete data, and continuous data, and you have learned the method. But today we are taking it beyond it, and we are going to cover other aspect of the mean. And what we are going to discuss today is actually harmonic mean and geometric mean. Why these means are important? Because it actually somewhere in some of the times, yeah, some of the places, arithmetic mean is either misleading or is not useful. So if I have certain specific problems, like I want to find out CAGR, compounded annual growth, in my sales or in my GDP, simple arithmetic will not help me to find out CAGR or IRR. You would have studied in financial management if that subject you have already studied. In that case, other kind of measure of mean will be helping me. Somewhere geometric means is helpful, and in other places harmonic mean is helpful. And today we are going to cover both of these type of means. We will do certain calculation, we will find out their nature, computation, and finally which is suitable in which type of situation. So let us begin. In your slide, all three type of mean, in fact all four type of mean is given. And I'm sorry that the color of harmonic mean is different. So it is it is actually thrown away from all these three, and the reason might be because harmonic mean actually reciprocate everything, because it takes, like, it reverse everything. 1 by 20, 1 by 30, so all the values I have to take uh, the reciprocal of all the values to estimate this mean. So these three means are not agree that harmonic mean should be placed with me. Send it to the right, and even they hadn't allowed harmonic mean to get the color. Sorry for this. Okay. So coming to actually arithmetic mean, what it is, I simply add up the values and divided it by n. And if it is a group data, then I can calculate the arithmetic mean by just taking the frequency fx upon f, right? And if it is a continuous data, then I have to take the midpoint of each range, and then actually I need to do it like this. I mean, then I have to multiply midpoint with frequency and then divide it by f, right? So I can calculate the arithmetic mean either by using the simple or direct method, or I can use the assumed mean method that we discussed in the previous class. How weighted mean is different, because here I'm not giving equal importance to all values as I have done in arithmetic mean case. I am calculating weighted mean when I have to assign different weight to some of the values. For example, your mother asked you to bring vegetables from the market, and she said that you need to have 4 kgs of onions, which are priced rupees 20 each kg, and say 2 kg of potatoes, the price of which is rupees 15 each kg. 1.5 kg of tomatoes, worth rupees 30 per kg, and 1 kg of say brinjals. Others are not liking it, but I am liking it. Brinjals, I love it. Say 1 kg, not 30 kg. Okay, price is 25 per kg ले लेते हैं, and half kg of say ginger, worth rupees 50 per kg. Now, if somebody tells you, okay, find out the mean of it, and you said, okay, in mean what I do, I usually take the total. So what is actually the quantity of vegetable I'm having right now? 4 plus 2, 6, 7, 7.5, 8, 9. Okay, I'm having 9 kg of vegetable. So what I can do, I'll find out the total cost, which is 50 plus 25, 75, and then 105. Okay, it's 120, 140. Okay, the total cost per kg, I mean, total cost is 150, 140, and then 9 kg of vegetables I'm having. So the average cost is 9 1 9, 5, 9, 9 5 is 45, then 5, 9 5 is 45, okay, per kg. This is your average. So is it a correct figure? No, because price of all the vegetable differs from each other. And here, weighted average mean is actually addressing this limitations of the mean, which is assigning equal weight to all the values there, and it will actually assign a different weight to each value. And if I look at the example which I just created, I can say the highest weight should be assigned to what? Potatoes. And what is the weight of potato? I 4 kg of potatoes are there out of 9. We'll just try to make it 10. So the calculation become easy. 6, 7, 7.5, 8, and 9. Let us make it 1.5. Then ginger, okay, or we can make it 1.5, and we can make it 0.5. Now this is 2, 3, 3.5, no, still not 10. 4 to 6, 7, 7.5, 8, 9, 1 kg, 10. Now this is fine. 6, 7, 7.5, 8, 9, 10, right? So now the total number of vegetables we have is 10 kg, where and the highest is like onions. So I have to give 40% of the weight to what? Onions. And then I have to give 20% of the weight to potatoes, and I have to give 1.5 means 15% weight to tomatoes. And I have to give 15% weight to brinjals. And lastly, I have to give 10% weight to ginger. One by 10. This will give me the value of what? 0, isn't it? So now what I have to do? I have to multiply the price with the weights to get the exact average spending. The more I would have spent it on the costly item like ginger, the more my mean will be. The more I have spent it on the cheaper item like potatoes, my mean will be lesser. So if I solve it at one go, it is 0.4 into 20 plus 0.2 into 15 plus 0.30 into, sorry, 1.5 into 25 plus 1 into 50, and this will give me the total weight of 8, 4 to the 8 plus 2, 15 to the 30, so it is 33 plus 1.5 into 25 is, oh sorry, this is 0.15, not 1. So it is 0.15 into 25, answer is 3.75 plus 1 into 50 is, oh, 1, 2, 3, 4, 5, 1, 2, 3, something is missing, okay, 0.2, 15 to, this is 8, this is 3, this is 3.75, am I missing something? 1.5 into 30, 1.5 into 30, okay, one thing is still remaining, and which is 1.15 into 30. Okay, now, so 15, 3 is 45, this will give me the value of 4.5, and this will give me the value of 1 into 0.1 into 5 is 5. And my total will be 8 plus 3 plus 3.75 plus 4.5 plus 5. So this will give 5, 5 or 3, 8, 11 and 19 and 0.75. So this will give me the value 19.75. So my average cost per kg is 19.75. And this is the outcome of weighted average. So remember, all the means are not suitable everywhere. We have the weighted mean, and now even weighted means will not serve all the purpose. As as I talked about, like if the problem is related to finding IRR, CAGR or average speed, then this will not work, and then other type of means will be providing me a solution like geometric mean or harmonic mean in case of average speed. Okay, so let us go ahead and learn about more type of this geometric mean. So this is something, that will confuse you at first glance. You start feeling, oh, it's very complex. Let me leave it. Even I experienced that initially. I thought, oh, it is multiplying the things. It's difficult, but actually it is something which is very useful if you have the understanding of it. And things are complex until unless you want them to be complex. If you start taking them lightly, then they become a tool for enjoyment, right? You start enjoying it, and then that will make your life simpler, right? So coming back, the formula for the geometric mean is nothing but you have to add up all, you have to take the product of all the values, and then you have to take the root of that value. So suppose I have 5 value of which I want to find out the geometric mean, then I have to take the fifth root of the product of this summation xn, right? In this way, I can find out uh, the geometric mean of any value, and you can interpret this also, right? 1 by 2 is half, and 1 by 4 is 25%, 1 by 5 is 20%, so on and so forth, right? So if you take the half value, it is under root. If you take 1 by 3, it's cube root. If you take 1 by 4, it's square root, so on and so forth. So where we can use geometric mean, we can use it if I want to find out CAGR, if I want to find RR, IRR, if I want to find out the return of my portfolio or the population growth, because these things are growing at a compounding rate. So the growth is itself is becoming a part of uh, the actual value, right? So in the case of compound interest, so interest become a part of principal. So that kind of problem cannot be handled by the simple average mean. This kind of problem can be handled by geometric mean, and geometric mean is where we can tackle this kind of problem. For geometric mean for ungrouped data, what you have to do, you have to multiply all the values given, then take the root value, and I mean if you have 3 values, 1 by 3, so you have to take the cube root. If you have 4 values, 1 by 4 quad root, and so on and so forth. If you have 10 values, then you have to take 1 by 10 as its root. So you have to take the 10th root of it, and you will get the output. And this is one of the example which is given here. So I have to find out the geometric mean of 2, 4 and 8. So I have 3 values. The first thing which I have to do according to this is multiply 2 into 4 into 8, and my answer is 2 4 is 8, 8 is 64. Total is 64, right? And I have to take the cube root of 64. If I'll take the cube root of 64, my answer is 4, right? Or you can take it like 64 divided by 1 by 3, and your answer is 4, right? Which means that 4 into 4 into 4 is equal to 64. Correct? So this is how we solve it, and then we have certain problems to try. Geometric means of 3 and 27. So what you have to do? Remember, you have to take the product of it quickly. 3 into 27. So this will give you 3 7 is 21, 2 3 2 is 6, and 7. So this will give you the value of 71. Is it? 3 7 is 21, 1, 3 2 is 7. So you'll get the value 71. Then you have to take the cube root of 71. So cube root of 71, not cube root, in fact under root of 71, because two values are there, no? So you have to take under root of 71, or even if you are not writing it, then it also, it again it means I am taking the square root. So under root 71 will give you the value 71 under root 8.46. The answer is 8.46. If I have to find out the geometric mean of three values, then I have to take the product of three values and my n becomes 3, and the formula is like n by x n. So in this case I have to take x1, x2, x3, product of all these three. So product of x1 into product of x2 into product of x3, and then you have to take the nth root, any third root of it. So how I'm going to solve it? Let us begin. 10 into 12.5 into 125, and this will give me the total of 15,625. Right? You have to you simply need to multiply all the numbers, and then you have to take the cube root of, because I'm having three values 1, 2, 3. So my n is 3, and I always place n here, right? So nth root of, or is in case this cube root of 15,625. Now how to solve the problem related to cube root? There are two ways. Either you can use the logarithm. If you don't want to use the logarithm, let's do it using the calculator. So I open the calculator which is there, right? So what I'm going to do, I'll select the value for which I need a cube root or nth root. So in this case my value is 15,625. Then I need to select this formula x y. So this is my y, this is my y in this case, and this is my x. Okay, so if I take this third root of this is like 3, third root, the answer will is 25. My answer is 25. So either you can use the scientific calculator and try to find out this function where x refers to number of observation n, this is for n, and this is actually the value for which you want nth root, right? And you can easily find out the value. Otherwise you can use the logarithm. So I don't want to discuss the logarithm here because that will divert my lecture. So coming to the fourth, so the fourth value, or if I want to find out the geometric mean of this, then what I'm going to do, I'm going to take the quick product of it, 2650 into 85, and keep in mind we have the four values, so we have to take the quad root of it. So and the total is like of all this value is, let me write it neatly, it is 143, the total is 1436500. So this is the total 1436500, and then I have to take the quad root of it. So my solution will be like 41436500, and I'm again going to solve it using the calculator. Then what it is, 1436500, then selecting the root x root y, which is 4, and answer, and my answer is 4, sorry, 13 into 26 into 50 into 5, answer is, okay, actually I don't know, no, this is not the answer of it. Okay, that's why I was getting a wrong answer. 13 into 26 into 50 into 5, and the answer is 84,500. So my product is 84,500. So I'm going to take the quad root of it. So quad root of fourth root of 84,500, and let me find out what is my answer. So if I take the quad root of this, answer is 17. So the geometric mean of this is 17. So if you multiply 17 four times, you will get this answer: 17 into 17 into 17 into 17, and you will be finding the value almost near to it, because I am ignoring the decimals, right? So in this way you can find out the geometric mean. So in the geometric mean of the fourth problem is 17. This is 25. Let me use some other color. Okay, let's take the green. So it is, so first answer is 8.46. Second answer is 25. Third answer is 17. This will give the value 25, right? And then coming to the next question, which is find CAGR if money is triple in 10 years. So if your money triples in 10 years, what is CAGR? So if I'll assume that my right now I'm having 1 rupee. In 10 years, this becomes 3 rupees. So what I have to do? I have to find out the 10th root of 3. So 3 by 1 is equal to 3, and 10th root of 3. 10th root of 3, and this will give you the answer. And let me quickly check out what the answer is. So again I have to do same thing, 3 cube root, and I have to put 10. So this is 10 and answer. So my answer is 1.11, and since actually it gives you the value 1 plus I, and here I have to deduct 1 from it, answer is 11.11, which is 11%. So I can conclude that if my money grows at 11% per annum, it will become triple in 10 years. What I did, I simply divided the target value with the current value, or you can say amount with principal. So in future I'll be getting thrice, means 3, or I can take the 100 also, 300 if I'm having 100 right now. So it means that it becomes 3. So I have to take the 10th root of 3. So when I solve it, I get the answer 1.11, and because I have taken 1 plus I is equal to this, so I have to deduct 1 from it. I'll get 11% as the growth which is needed to triple your money in 10 years. Okay. And then the last one is like find out the annualized IRR of 1000 rupees bond, which is maturing at par in 12 years, but presently selling at, which is presently selling as 420. So this is even simpler. So I have 1000, right? Right now I have 420. 1000 divided by 420, okay, is equal to 1 plus I k power n Actually, I have to find out the value of n, and n is nothing but this will give me uh, so I want to find out the interest or growth rate. In this case, n is already given to me, and n is 12 years. So when n is 12 years, I have to find out the 12th root of the value which I got after dividing this by this. So if I divide 1000 by 420, 1000 by 420, my answer will be 2.38. So I can rewrite this. I can rewrite this as 2.38 का कौन सा रूट चाहिए हमें? 12th root. I need to find out the 12th root of 2.38. So what I did, 1000 divided by 420, this is this value, and then I have to find out the 12th root of it. Answer is 1.0749. So 1 plus I is equal to n is equal to 1.0749. So if I deduct this 1 from it, minus 1, I'll get the value of I, which is growth or interest. So this will give me the value 0.0749. So rounding off to the nearest decimal to 0.075, which is nothing but 7.5%. So I can say, if I purchase this bond at 420 rupees and it is maturing at par, I'll be getting back 1000 rupees on maturity. Then and this amount I'm getting after 12 years, then it is generating a return of 7.5%, annualized return of 7.5%. So this is how we use geometric mean for the calculation. And this is there is one more example on your screen. Your investment grows at 10% for the first year, 60% in the second year. What is the average growth rate? So first you need to find out the multiplier. If you would have practiced with financial management, it is something which something what we are doing. So first year it is growing at 10%, so I can see 1 plus I. I is interest rate. So 1 plus 0.10 is 1.10. This is my first year growth, and in the second year it is growing at 60%. So if I want to make the calculation for this, what I have to do? So I again have to use 1 plus I, right? 1 plus 0.60, which will give me the value 1.60. So I have used this value here and this value here, right? Then what I have to do? I have to multiply both of these values, and the resultant value is this. This is resultant value, and then I have to take because it only 2 years are there, then I have to take under root of this, right? Because 2 years I want to find out the growth rate, average growth rate for 2 years only. So I have to take under root of 1.76, and this will give me 1.326. And if I deduct 1, because I have taken 1 point I na, so if I deduct this 1 from this value, I'll get 0.326, which is nothing but 32.66% growth. So if my investment grow 10% in the first year and then 60% in the second year, so on an average I would have got 32.6%. If I would have taken the arithmetic mean actually is not allowing the compound interest or interest received to become a part of principal. It is simply taking the values. So to take out this growth, compounding growth effect into consideration, I have to use geometric mean, and in that case I'll get the exact average, which is exact average growth, which is 32.6 in this case. So another way to do it is use of logs. If you have the knowledge of log, then this is the best way to do it. Then you are not needing a scientific calculator to do it, but you need a log and log table, right? Log and anti-log table. And then coming to the next part, the statistical toolbox, when to use which, when to use median, when to use geometric mean. So you have to use the geometric mean when you want to find out the growth rate, you want to find out the investment return, you want to find out the exponential trend, or when the values are to be multiplied, then you can use the geometric mean even for indices calculation. And then coming to the next part, correlation and standard are the measure of relationship and variability. So it is not fitting here. Coming to harmonic mean. Now what is harmonic mean? Harmonic mean is actually a reciprocal of arithmetic, reciprocal of arithmetic mean, or you can say it's the mean of reciprocal, not reciprocal of arithmetic mean. Harmonic mean is actually arithmetic mean of the reciprocal, one by one by one by any value which you want to find out the harmonic mean of, you have to take the reciprocal. Suppose you want to find out the harmonic mean of 10 and 5, so you have to take one reciprocal of it, 1 by 10 and 1 by 5, and then you need to solve it, right? Correct. And then you have to take the average, obviously two values divided by 2, three values divided by 3, and so on and so forth, depending on your n. So when you can use the harmonic mean, if you want to find out the average speed, you want to find out the cost per unit, you want to find out the electrical resistance in parallel circuit. So it is very useful in physics. Coming to the problem, if you are handling harmonic mean for ungrouped data, then what you have to do? You have to, first of all, you have to take reciprocal of all the numbers which are there for which you want to find out the harmonic mean. Then find out the total value which you have obtained by solving the reciprocal, divided it by n, number of observation obviously, and you will find the result. So we will take a quick look at this calculation. So we have three number 2, 4 and 8, and I want to find out these are my three number 2, 4 and 8. The first thing is I have to take the reciprocal of all these number 1 by 2 and plus 1 by 4 plus 1 by 8, and then so 1 by 2 is 0.5, 1 by 4 is 0.25, and 1 by 8 is 0.125. So if I take the total of it, I'll get the value 0.875. Okay, then you just need to take the average of it by dividing it by 3, and you'll, sorry, divide 3 because you have taken the reciprocal, no? So then you have to n upon result, right, to get the actual harmonic mean. So n in this case is 3 and result is 0.0, no, 0.875, and this will give you the answer as 3.43. So how you can interpret it? The harmonic mean is 3.43 and it is always less than equal to geometric mean, which is 4 in this case for the same data set, right? And it is mathematically guaranteed that harmonic mean is always less than equal to geometric mean. Let me quickly check how to calculate the harmonic mean of the group data, and the problem is there. So first you travel at a speed of 5, then at 60, then at 80. Speed and then frequency. Okay, before coming to this, let me have a quick look of this. I travel 50 kilometers at 80, speed of 80, and then 50 kilometers at the speed of 40. So what is my average speed? So how you are going to solve it? You simply need to apply, take the reciprocal of first speed is 80 and then second speed is 40. Then once you have this calculation with you, then you have to take 1 by 80 is how much and 1 by 40 is how much. So I'm going to calculate it. 1 by 80 is giving you the value 0.0125 is my first value, and 1 by 40 is 0.25 is my second value, 0.25. When I add both of these value, I'll get 0.0375 as output. And then you need to, because there are two numbers, then you have to divide 2 by this value. So my n is 2. So what you have to do? So my n is 2. So n is 2 divided by 0.0375. Correct? But now you just come to the conclusion. 2 divided by 0.0375 and your answer is 553.33 kilometer per hour in this case. So you can say that your average speed is 53.33 kilometer, right? So then we can calculate it for group data, but I don't think it is required here at this level, because if we move down into the calculation, then what we have to do, we have to find out the reciprocal of all the speeds and then assigning a weight to get the final output. No, then I have to actually, how I can solve it? I have to take like 1 by 40, 1 by 60 and 1 by 80. First of all, I have to take the value of all the reciprocal, and then I have to take the total n 5, 8, 13 and 320. So I have to divide 20 by the output which I have obtained from here, right, from the reciprocal, to get the final output, and the result will be my answer. You will get the answer, right, by dividing 20 from the calculation of these reciprocal values, right. In this way you can solve even the group data's problem for calculation of harmonic mean, right. So next is, okay, that is already given here, the solution. Divide each frequency by midpoint, f by x. So it is like 5 by 40 is 0.125, 8 by 60. Okay, you are doing it initially only. I mean, you are dividing 5 by 40. Instead of taking 1, you are dividing it 5 by 40 and then 8 by 60 and then 7 by, in this case 7 by 80, right. So what you are doing, you are actually finding out the value by dividing it the frequency by the number, and you will get these answer, this and then taking the sum of all fx values. Since once you get these values, and this is output, even if you would have solved it the method I have told you just now, you will get the same answer. So when you divide 20 by this value which you have obtained by this calculation, you will get your final average speed. So if you are you have traveled at 40 for 5 kilometers, 60 for 8 kilometers, 80 for 7 kilometers, or 7 times. Frequency means times. So 5 times I have traveled with 40, 8 times I have traveled with 60, and 7 times I have traveled with 80. Then what I need to do, I just need to take instead of taking the values 1 by, I'll take the frequency wise, like 5 by 40, 8 by 60, and I've done this here, right. And then you'll get the final answer of the reciprocal sum, and you need to divide the total of total frequency is 20, so n is 20, 20 divided by this value, you will get the harmonic mean. So on an average, you would be traveling at the speed of 57.9 kilometers throughout. right? So coming to the toolbox, arithmetic means you can where you can use, you know very well where to use mode and where to use the harmonic mean. So because now we are discussing about the harmonic mean, so where we can use it to find out the average rate of speed, fuel efficiency, ratios. So ratios, and even when you are doing the data, sorry, equity research or equity analysis, there you will be handling with a lot of ratios which are giving you the picture uh, about your company. If you are doing a comparative analysis, relative valuation, or even if you want to take the decision about whether to invest in particular stocks or not. So these ratio is are helping you to compare your company with other with the industry and other companies which are called the companies which are your peer group. In that case also, this harmonic mean will help you a lot, and that is why I have discussed it here, because in business, geometric mean has its own importance, harmonic mean has its own importance, weighted mean has its own importance. So we will be having deeper look into weighted average mean also, and and then we will move to the other part of the question later. So as of now, I'm calling it a day. See you in the next class. So be attentive, come to the next class for sure, and I hope by the time you'll finish this course, you start enjoying the numbers and you are going to use it to make your life simple. Okay, thank you.